All right. Hi, everyone. Thanks for joining us tonight with the Houston React Developers Group. My name is Tracy. I will be the facilitator for the event this evening. We also have Nick, who will be managing all of the incoming comments. And we also have Fabian, who is the organizer of our group. He's a co-organizer on the camera right now. Tonight's topic is React hooks the right way with Kevin. And just before we get started, we'll let Kevin introduce himself. But before we get started, just wanted to give everyone a heads up as the presentation takes place tonight. Kevin will give opportunities for questions throughout, and then we'll also leave time for questions at the end. So feel free to leave those questions in the chat as we go along. Before we get started, there are a couple announcements. The Houston React Developer Group always wants to hear from you. So if you have any questions or topics that you want us to cover, Nick, go ahead and drop that in the chat for everybody. You can fill out that survey and let us know of any future topics you want to hear about. Or if you're also interested in presenting, there's another question at the end of the survey. It's only 2 questions. And if you feel like presenting, go ahead and go to the next screen and leave us your contact info and we will get with you. I think everybody is good to go. So everyone go ahead and turn off cameras and mute yourself. And we are going to give it over to Kevin. Take it away.
Oh, muted. Hey, how's everybody doing? I'm Kevin. This is my presentation on React hooks gotchas. And I had a different title for this. It was called You're Doing React Wrong, but I thought I'd be a little bit nicer about it because I'm not really sure. My name is Kevin. I've got over 15 years of web development experience and over 6 years with React. I started with React in 2015, and I did it on like a website for my game that I made. And from there, I started using it in a professional setting and have been using it since then. For the talk today, we're going to go over the problems React is solving and how React renders. Then we're going to talk about the problems hooks are solving and how to identify those problems, the problems with using hooks incorrectly. And then we're going to go over the common problems that I see out in the wild. I see a lot of problems all the time, and I really want to go through those. But to get to that point, we really do need to figure out what React does and how it works. Because if you don't know those, it's not going to make sense once you get to the hooks part. What is React? How did React come to be made? At the time when React was made, there were a bunch of other frameworks out there. Now, I wouldn't really call jQuery a framework, but it was a solution that allowed you to do DOM manipulation and to hit things in the DOM. And actually, jQuery was used by every single one of these other frameworks. So Knockout, Ember, Angular JS, and Backbone JS, those were all using jQuery behind the scenes. With React, it was more of a competitor to jQuery than it was a competitor to any of these other frameworks. Now, today, React is an entire well, it's a library, but you can use it like it's a framework. You can build your whole app in React. Back then, you would only really be able to build your app using, well, I guess what it would be is that React wasn't designed to be the entire app. And if you look at this post by Lee Byron 8 years ago, he said that React helps with a problem of complex UI rendering, but it also works well with Backbone. And that's pretty much how it was meant to be, is that you would have an existing site that had some framework that you used, and then you would add React to it in little pieces where you needed it, because it would help you with those really complex tasks. It wasn't really meant to be the whole site. And that's why React is a component library, which is actually really nice, because your app used to look like this, where there's just, here's your app laid out in HTML and some little bit of JavaScript here and maybe some framework. And then this is what it would look like with React in it, where you'd have these little pieces of React spread out throughout the app. This is what a React component looks like. Now, I'm pretty sure all of you know how this looks like, but we're going to look at how React reacts to changes. And this is important to understand. Changes come from props. They can come from state. They can come from context or the parent element re-rendering. If the parent element re-renders, it does cause a change in your child components, and that would also trigger a re-render. So changing a component re-renders it. That's really important to remember. Now, when I'm using the word re-render, that re-renders to the virtual DOM. And what it actually does is it creates a new virtual DOM. And then it compares the current and previous virtual DOMs together to see if there are any changes. And if there are any changes, and I mean like one little change in your component, that is going to then cause that component to render to the actual DOM. And as we know, DOM renders are very expensive. So the virtual DOM diffs happen after you re-render. A re-render is triggered from a change, and then a change comes from props, state, context, and the parent element re-rendering. DOM rendering is really slow, and so that's why the virtual DOM is there. It's there to be a faster alternative where you don't have to actually render the graphics and do painting and CSS and all this stuff. All it does is it renders to the virtual DOM, and then the virtual DOM does that diff and then checks to see if it should render to the actual DOM. And that at the time was a really big performance enhancement. There are better ways of doing this today, but this is how React still works. The virtual DOM diffs are expensive as well, but just not as expensive as writing to the DOM. And we do want to avoid virtual DOM diffs where we can, because if you're doing a lot of virtual DOM diffs, it actually is going to have a performance impact on your application. And I can explain why that is. First, let's take a look at class versus function components. Over here on the left, we've got a class component. Over here on the right, we have a function component. They look virtually identical. I wrote them in a very similar way. Typically, I would deconstruct the props here so you wouldn't even see the word props, but I'm writing them to look similar on purpose because I want to show you something. The class component will have these methods here, like lifecycle methods and things up at the top. Function components have hooks, so they look like they're identical, except that the only thing that updates when you receive a change to a React component in a class component, only this render method changes. Now, there's some other functions that get called too, like should component update, or maybe component did change, or any. There are some other lifecycle methods that run too, but typically just your render method is running. In a function component, when a change occurs, the entire function gets called again. So everything from here down gets called again. In fact, including all these args, everything gets passed in again. All your hooks rerun again, and then this return happens. So if you understand how that works, that's going to make hooks make a lot more sense. Class components render is essentially the entire function component. Hooks are not a replacement for class methods, but they provide similar functionality. This is a React component with JSX. It's a text input. It doesn't matter really what's in here, but at least see there's a div, there's a label, there's an input. Great. This is what it looks like without JSX. This is what Babel is going to do behind the scenes. There are other transpilers that can take JSX and convert them to React-specific JSX. This is what React does behind the scenes. Other libraries like Solid.js would do it differently. And in React, it does something called react.createElement. And this function creates a React component. And then you can take that React component and you can pass it props or children. In this case, we're not passing props to the div. We are passing props to the label. And then the children of the label is this label text coming from these props up here. It doesn't really matter the specifics. What's important, though, is to realize all of these components here are re-rendered anytime a prop changes. And if any other change is made in your component, that will also re-render all of this. It doesn't matter if just the name prop changed. It's not going to like look over here and say, oh, well, that one's using name and this one's using name. I'm going to re-render just those. No. It re-renders everything. All of this here. If you have a 1,000-line component in a huge render function or a huge return function in your function component, all of that will get re-rendered again if a change is made. So it's very important to understand that. And that's why I'm showing this without JSX, so you can see past the magic. Hooks. You're probably now wondering, like, what are hooks? Even though you're probably using them, right? But what are hooks? React hooks are all about state, right? This is what you learned, except it's wrong. It's completely wrong. React hooks are all about memoization. In the docs for React hooks, you'll see that the number one item is useState, except for this is a misconception. useState is actually the weird hook. All of the other hooks deal with memoization, and useState does too, but in a different way. So because all hooks memoize values, you're probably now wondering, what is memoization? Memo is short for memorandum. Memorandum means to be remembered. So memoizing something means remembering something about it. And this is a memoized function I wrote myself. We'll go through it. It is memoization, like a very simple way to look at memoization. And what we're doing here is we're comparing the args that were passed in Now, with the args that were passed in last time, up here with the memoize, we're actually wrapping a function with this memoization functionality. You could just write every function with this built into it, but you could also do this where you call it and pass it a function, and it returns you a brand new function. So this function that we're doing now looks at the arguments, and it checks to make sure every single one is the same. If all the args are the same, then we return the previous value. We do not compute the function again. But if the args have changed, then we do compute the function again. We store that in the previous value and we return it. If any of the syntax looks kind of weird to you, like why did he tab there, hit enter or something like that, it's hard to fit things in slides. So if it looks weird, it's probably because of that. I would normally never write like a mutation in the middle of my return statements ternary, but I'm doing it here for just the slides make it easier to read. So it's important to note that a memoization in terms of this particular function that I wrote looks at the arguments and says, have any of these arguments changed? If they have, I will recompute. Otherwise, I will return you the value I got last time. There's no reason to recompute. The arguments have not changed. Here's an add function. It's very simple, right? You have number 1, number 2. They come in as arguments, and you add them together. And the return value, this is using an implicit return. The return value gets to go on the other side of the equal sign. Now we're going to memoize that add function. So we've wrapped the add function in memoize, and that's going to create us a memoized add function. Now we're going to do some math here. We're going to call memoized add, and we're going to pass it 2 arguments. That's going to be number 1 and number 2. We're going to add them together, and we get 12. Because it's the first time we've used this function, we're going to execute it. And it stores these arguments, and it stores this value. The second time we call it right here, well, we've already done that before, and the arguments have not changed. Because the arguments are unchanged, we're going to return the previous value you had. We're not going to recompute that. It doesn't make as much sense with an add function where it's so small, but with larger functions like hooks and other things where you don't want your component to re-render, that's where this is important. Now, the first thing I want to see is anybody had any questions? I'm not seeing any in the chat, so I'll go and continue. But if anybody asks any questions, I can discuss them. So my actual talk is not really you're doing React hooks. It's more like memoize all the things. And that's how you're going to do React hooks. So how does memoization relate to React hooks? There is a use callback hook that you've probably used. Hopefully, if you're using hooks, hopefully you use this one. Here's an example with the text input. It has a use callback. This allows you to memoize a function with the second arg. The second arg is like my memoize function that I wrote, because what happens is React is going to look through this array. Right now, there's nothing in it. But if you pass things into that array, it'll loop through them. It'll check if any of them have changed. If any of them have changed since last time, then it will return you a new callback function. So this whole function that you passed here will only get created again. Well, I guess it's getting created every time, but it'll only return you the new one when this second arg has seen a change. So when it's looping through here and looking through the values, if it sees there's been a change, then it will return you a brand new callback function. And then that's going to be value change, and that's going to come down here. So thing to keep in mind, when this text input re-renders, it will call the use callback again. And that use callback is going to be passed a new function and a bunch of second args. If the second args change, then it will make that new one, and then it will return you a new value change. Otherwise, you'll get the old one. Now, what happens here is that the virtual DOM is going to get this input here. And if that virtual DOM notices that the onChange function has changed, then it's going to render to the DOM. That's why this memoization is important. If you're memoizing, actually, hang on, let me think. If you're not memoizing this, then the onChange will see a new value every single time, and it will re-render to the DOM every single time a change occurs. Changes come from props, state, context, or the parent element re-rendering. Here's another example where we memoize by props. So I've got a user ID prop, and I have memoized this callback function based on the value of user ID. So if user ID gets changed, the next time this component re-renders, it will see that user ID has changed. It'll give me a brand new callback function with the latest user ID in it, and then we can pass that down here. Use memo is another hook. It's actually identical to use callback. If you look here, this looks exactly the same. What is the difference between use memo and use callback? Use memo takes a function, but it returns you the value. So use callback returns you the actual function. Use memo returns you the value of that function. And in this case, we are now memoizing a value instead of memoizing a function. In terms of like Knockout or solid.js or any other, like maybe even Vue, this is what's called a computed or derived value. You're taking one value and you're deriving another value based on it and then memoizing that, and then now you've got your value. You can also memoize many props. So instead of just one prop, you can memoize on many props. You probably know this. I'm assuming people that you're using hooks today know all these things, but we're going to go over it so that we can understand anything you might be missing. So when we memoize many props, there are two props coming in, an onChange and a user ID, and we are memorizing in our array both of those. The reason both of those are used is not because they're both being passed in, but because we're using both of them in our use callback function. So you notice here, it calls the onChange we got in, passes the event. The event is local, so we don't need to memoize that. It's not even possible to. It's just something that when the callback gets called, this gets passed in. And then the user ID is something that came from props as well. We also need to memoize on that. So if the user ID or the onChange function changes, we are then going to create a new callback and pass it into the onChange here. That way, we're always using the latest values. Use context is another hook. React Context API avoids passing props. So instead of passing props into the component, we can use the same two args down here, but now one is coming from form context and one is coming from user context. That's important because these are two different contexts. If any one of these updates, it causes a change in your component, and a change will cause this entire thing to re-render, meaning the entire function from here to here gets called, and it will grab either the old user the onChange function that was there before or the new one that it's been updated to. And then when you're looking down here, it's going to notice a change in one of those, and it will create a new value change and then pass that down to your onChange function. This allows us to memoize by context. Use context also forces re-renders. So keep that in mind. If a change is made to context, it forces the entire component to re-render. UseEffect is another hook. UseEffect is a hook that allows you to memoize side effects. That's really weird. Memoizing side effects? How can you even do that? But that's what it does. It's a little bit complicated if you've never used it. UseEffect takes a function. Well, actually, this is the function right here. And that function takes a return value. And that return value is another function. That second function closes over any values that you had in your main function. And what happens is that UseEffect will be looking for second args here to see if it should rerun this main function. It also will run this return statement if this value has changed. It'll also run that return statement when your component unmounts. So this kind of gives you the old functionality you would have had with component did mount, component will unmount. It's all done in the UseEffect, but it's a little bit different. This return value here is because it's a function. What happens is the first time your component loads, the UseEffect runs after your component has actually mounted to the DOM. Then the UseEffect runs. It does not run server side. It calls this function, which calls the tracking. So the tracking occurred with the current user ID. Then we return a function to the UseEffect that includes a tracking like offline. The user's offline. I don't know why I'm doing that, but that's how I wrote this slide. And that also has a user ID in it. This user ID is the closed over version of the user ID from when the component mounted. If the user ID prop changes, then what will happen is this return statement will get called with the old user ID saying that user is offline, and then it'll call this UseEffect function anew with the new user ID that was there. And it will then create a new return value that will eventually get called when this component unmounts or when another user ID change occurs. UserF is maybe not my most favorite hook, but it is one of the most interesting hooks because you're probably using it wrong. Not wrong. Oh, I'm sorry. That's like a complete. You're probably not using it to its fullest potential. So useRef allows you to memoize DOM references, and you can use it like this. You call useRef. It gives you a ref. You can pass in your DOM element, and now you have access to the DOM element after it has mounted. Before it's mounted, it's set to undefined. And useRef, unlike the other hooks we've talked about, doesn't cause changes in your component. So what does that mean, really? That means it's extremely powerful. And with great power comes great responsibility. But useRef is super important. Here's an example. Here's the text input, same as we had before. It's got an on change. But now we never update the hook. This means we can prevent changes to the virtual DOM, which means the actual DOM will never change or never be re-rendered or whatever, right? Like same thing. I guess it won't ever change. So what happens here is we're doing useRef, we're making an onChange reference, and then right here we're doing onChange ref.current equals onChange. So we're setting the ref to our onChange function that came from props. Now we can use that inside of our callback function, and it will always be the most up-to-date value of it. And we don't have to pass any second props here. And what that means is value changed will never change. But the value change function, whenever called, will always be calling the latest on change. So I don't want to get into this like too deep yet. We'll come back to it. We definitely will come back to it. There's another example, and you're going to see how we can use useRef. Now we can talk about state. Finally, useState, right? This is what they're supposed to teach you first. But I always do it last because it's like the weird one, right? Everything else made sense until now. So useState is for local state. What it allows you to do is force your component to re-render when a setter is called. So what happens when useState runs? The first thing happens, you call this function, useState gets called, it passes this value into value the very first time. After that, it's set. It doesn't ever set that value again. This one doesn't do anything after the first mount. Then it takes this value and it passes it down here. Everything's good. And we also pass this value change function like we've had every other example. Now, if the value has changed, it's going to call the setter. That's going to pass this value in, and that's going to cause your component to re-render because a change to state occurred. So because a change occurred, that will cause the component to re-render. useState is going to get called, and then it's going to return you the same set value function you had before. That doesn't change, but the value will have changed because there was a change in it, right? That's why a re-render occurred. You'll get a new value, and then you can pass that down into your input. So useState forces re-renders. And these are only some of the hooks. And now we're going to go over a simple example of bad hooks. But before that, I want to go over some of the questions I'm seeing in chat here. So somebody said, should you use children and when should you use memo? So you can use children, yes. And I use children all the time. You can even memoize children, which is kind of crazy. They do it in Redux. I wouldn't. The React Redux library does memoize children. I memoize children in a little bit different way, and we'll go over that. If all hooks, so somebody else asked, if all hooks do memoization, why do we need use callback when we use useEffect? useEffect is for side effects, and use callback allows you to pass a function somewhere. So useEffect will execute a function based on some kind of event occurring, whereas a callback would give you the function that then executes when that event occurs. So I guess you could do an add event listener with useEffect, and that would be the same kind of thing as a use callback, but then you need a reference to that DOM element to add the event listener. So yeah, you really do want to do use callback a lot. And somebody else asked, is it better to use useRef or useState for inputs in forms? That is a very, very good question. I wrote my own form library, and I do a combination of useState and useRef depending on the needs, because it's not that I do a combination of it or that I'm using it in both places at different times. I use refs in the provider component where I have a context, and I use state where I'm doing my local state inside of each component, but I don't do it at the context provider level because that would force all of my consumers to re-render. And we'll go over that as well. And I think useRef, in terms of like efficiency, useRef will always be faster, but it is going to result in worse code. Like I said, it's very powerful, but you got to be careful with it. So now we're going to look at an example of bad hooks. And I want you to try to figure out what is wrong with this. And feel free to put it in chat if you want, even though it might be way in the past by the time I get to see it. So what is wrong with this? I'm telling you there's something wrong here. But what is it? Well, number one, we are putting a hook in the middle of our DOM render. So yes, you can do this, and it will sometimes work, but hooks can't be conditional. So if you have a condition that gets put up here, this is going to break React because somebody put a hook down here. Hooks depend on the order of execution. That's how React does them. It doesn't know, like, you're not naming this function that you've passed in. There's no string or identifier or anything. The only way React knows that it is a use callback or a use effect or a use state is that it's been done in a certain order. And if it happens in that same order, then everything's good. But if the order changes, React is going to freak out and potentially even error, and your app just breaks randomly, and you won't even know why. The other thing is that if you're putting a hook in the middle of your DOM, nobody's going to know it's there. I will definitely not be looking for it there. So that's another reason this is a problem. But there's more. Yes. You forgot to put this second arg here. So if you don't put the second arg, then what ends up happening is this creates a new callback every single time a change is made. So while you're trying to memoize with use callback, you're actually not memoizing at all, and you get no benefit. And React is supposed to not re-render to the DOM. That's where it gets its performance from, is not re-rendering to the DOM. But now we're forcing a re-render every single time. So you definitely don't want to do that. But hooks are so easy, right? They're magic. They're so good. But hooks are actually really tedious. Now, I like hooks and I understand the trade-offs, and that's why I'm okay using them. But if you don't understand hooks and you think they're easy, I would disagree with you a lot. And ESLint does not help you catch everything, but it does help you catch a lot of stuff. So if you use, and this is the thing is, as far as I know, the ESLint hooks library that comes with React is not built into the tooling that you can use. As far as I don't know if Create React App has it or Next or something. Hopefully they do have those ESLint rules built in, but I'm not exactly sure. I don't really know. But if you don't use the ESLint rules, the official ESLint rules with hooks, you're going to have lots of weird edge case bugs in your apps, and you're never going to be able to figure out why. ESLint really helps, but it just doesn't catch everything. For instance, it won't catch missing second args in custom hooks. So you have to write your custom hooks differently so that they can work with ESLint and work the way that you expect. If you're putting second, if you're expecting some kind of array and you're expecting ESLint to help you out, you probably should be writing that in a different way, because ESLint has no way to know. It only knows the official React hooks. It doesn't know any custom hooks. In general, not knowing hooks will be harmful to your app. So if you really don't understand hooks and you use them in your app, I think it's actually more harmful, because you can cause problems. Same with class components. If you don't understand how class methods work and binding this and all that stuff, like, it's going to cause problems as well. Concurrent mode, which is a different renderer for React, it needs proper use of hooks. And so concurrent mode renders your components asynchronously. And this is like a big thing, concurrent mode, but it hasn't really seen much use case. But I've used it, and I've gotten a tenfold increase when I use concurrent mode. But it's only in the experimental branch now. I think they had it in there for a while, and then they removed it. And I don't know what's going on. I don't even know if it's going to be in version 18. But it's a big deal if you want React to render really fast. But when it re-renders randomly, and it will cancel your renders mid-flight. So if you don't use hooks correctly and you don't memoize correctly, it's actually going to cause edge case bugs. For instance, you start doing a data call or something like that, right? And you didn't add any cancellation. Well, it's going to cancel your render and then re-render it. But if that data call comes in at a different time as a different data call, then you're going to have all these race conflicts randomly because you're using concurrent mode. So if you don't understand hooks, I really think your app is going to suffer. It's going to be a big problem. And it's just going to waste your time, because you're not going to try to look for problems. Good luck solving any of those. Hooks really do need memoization, and we used to have it with class components. Class components had memoization built in. Function components do not, and to use memoization with function components, you need hooks. But if you're not using hooks, or you're not memoizing properly, you're going to be lacking what you would have had with class components. So the first kind of memoization we're going to look at is props memoization. Props memoization is, here's one example. So these are all going to be examples of how we memoize props. Here's the should component update function for a class component. If you've never used this, that's fantastic. You never want to use this thing. But what it does is it allows you to control if a component re-renders based on this function returning true or false. And if you do any of this manually, you can cause tons of problems in your application, specifically for this component. Not the whole application, but this component. You can cause weird problems in it if you're not using it correctly, because hang on, let me see. I got my pointer back. Okay, good. Because should component update is extremely powerful. It's kind of like use ref, but it's a tricky way because you can basically tell it like, hey, no, don't re-render that prop that came in. Nah, don't worry about that. You don't need to re-render. That's like a tricky thing, but it allows you to memoize components. It's just you need to do a lot of things by hand, and I don't think you should ever use this. So this is I want you to look at something here real quick. This is a class component. It has text input extends component. So the next one we're going to look at text input extends pure component. What's the difference? Well, pure component also memoizes your component, but it does it for you. And what it does is a shallow compare of the current and the previous props that have come in. But pure component has no state. This .set state does not exist in a pure component. So you get memoization of props, but no state. And while that's really good for performance, it's probably not what you want in your application unless you're doing a full Redux build, which is, I've done that in the past, and I use pure component everywhere for it. The connect function from React Redux, you've probably seen this, it memoizes your components too. So instead of having to use pure component, you could just use the connect function as the higher order component, not the hooks. The higher order component of connect also memoizes. So here we're taking text input, we are calling connect on and passing text input, and then you can pass your map state to props, whatever. As long as map state to props is done correctly as well, then the connect function will do a shallow compare of the props in text input when they get changed, and it will choose to re-render or not, which is really nice for performance, which, you know, connect didn't have to do this memoization, but the fact that it came built in with it by default is really nice. There's also the memo function. This is an official React function that memoizes your components. I would say you should always use this now. I use this on every component at work. I'm not even joking. Every single component that gets written has this memo wrapping it because they are all props memoized. The benefit of doing this props memoization is that your components are deterministic. You can know exactly when that component will re-render, and when you ever have to look at performance problems, you know why it's happening. It's not randomly re-rendering because of other things. If your component, before I said a change occurs because of props, state, context, and the parent component re-rendering. If the parent component re-renders and the props have not changed, then this memo prevents that from making a change in your component. So you can actually prevent changes from the parent component by using this memo. So it takes out two of the possible avenues of your component re-rendering. It's very, very nice. But the syntax I showed you is actually wrong. Babel does this thing where it automatically adds a display name prop to your React components. And to do that, it's called @Babel preset React. If you might not even be having to worry about that. Maybe you're using Next, it does that for you. But you will have to write your memo functions like this. You will have to create a new variable with your memoed component and then export it that way. And then it will assign a default name for you, or display name, sorry. It'll assign the display name for you on this new component that gets output, which is what you want. You don't want to have to do that by hand. Just let Babel handle it. Function memoization is a way that we used to memoize functions. So in a class component, you would have a method on the class. And this method right here is nice because it never changes. So if you see here, this .value changed, it never, ever changes. Once this class is instantiated, meaning once it's been newed up by React, this function never, ever changes. Even if the inside changes, the outside, the reference to it never changes. Now, you're probably noticing something here in the constructor. We're doing this.value changed, which is what we're passing down here, equals this.value changed .bind this. What the heck is this going on here? Well, if you pass this.value changed somewhere without this context in it, then it won't know what class it's a part of, and it'll essentially be a static method. And this is a function of JavaScript prototypes, and it's really complex if you don't know how it works, and I really don't want to explain it either. But the important thing is we are overriding the value of this.value changed in the constructor. So when it gets newed up, we're overriding it with itself, but bound to this particular instance of this class, which is kind of crazy. A newer way, or a more modern way of thinking about it, is doing it like this with an equal sign. So instead of using this syntax, this method syntax, use the equal sign and a fat arrow. Fat arrows auto bind this, so you don't have to do that yourself. And this is only really important if you're using classes. If you're not using classes, it doesn't matter at all. I haven't used a class in so long, but I do see it in some legacy code. And this is the more modern way of doing it, but it's not supported by certain browsers. And your Babel version needs to be up to date enough to be able to use this, because it might not support it. And that's really only older Babels, but who knows? You might have a legacy project and it doesn't support this, and then you end up having problems. So, but this is the exact same syntax. And in fact, with hooks today, you can now do this. Use callback. This is the thing we were talking about before. Use callback is the same as adding a method to a class. So where you would have done that normally with classes, all of your functions would have been in methods. Now you can do that same thing with hooks, but you have to make sure you memoize it. Otherwise, it doesn't do anything. DOM memoization. Can we memoize the DOM? Well, that's actually what the virtual DOM is. It is DOM memoization. So to keep this in mind, any change you make to the virtual DOM renders the entire component to the DOM. Remember, I talked about that before. Keep this in mind because it's really important. And I'm going to look at the chat right now and answer some questions at this point. Is using an inline function for an input on change a bad idea? Yes, actually, it is absolutely a bad idea. If you put that inline function in there, it's going to cause that input to re-render every time a change is made, which could happen from 4 different places. And it's actually pretty horrible. So when I wrote my form library, the on change is always memoized. In fact, the on blur, the like everything is memoized. But the yeah, so like I would say, like, here's the thing with hooks. Memoize everything. We'll get into why. We're going to get into like the hooks problems, and you're going to be like, oh, I should have memoized everything. Oh my gosh. You'll see it when we get to something called the Memoization Cascade. Somebody said, I understand not fully understanding hooks can cause problems, but isn't working with hooks helpful to learn how to use it? Yeah. You should. Yeah. If you don't work with hooks, you won't learn them. But I've seen a lot of people with their function components, they'll just put code in there and not memoize it. And that causes like a whole slew of other issues. Somebody else says, I think that's it for the question, because some of these are getting answered as I'm talking. Somebody said, this is an interesting one. Said callback all the time question. Okay, so what use callback does is make it possible for the child component to use the callback and not to re-render if it's memoized. Yes, correct. Okay, great. Now we're going to go into hook scotches. Now this is where it's going to get kind of like intense here, because we're going to go through all these things and you're probably going to say, oh, I did that too. And you're going to start like, this is where we're going to get to the good stuff. Default prop values. Let's look at adding a default value to props. It seems like pretty straightforward, right? We have an onChange function here. I want a default value for this. Typically, you don't want a default value for an onChange, but it actually, there are reasons why you want to do this, and unit testing is a good example where you don't necessarily want to pass every prop. You just want to render some things. And so here's an onChange. I want a default value. How do I get a default value for this onChange function? You'll mostly have components that have, so in this example, it doesn't make as much sense. I just want to be clear about this. This is an input. This input does nothing really if you don't pass it an onChange function. It can't really do anything, right? There's no state. But there are lots of components that you write that do take callbacks that you don't necessarily have to pass the callback. And sometimes you won't pass the callback, or you won't pass a value or an object or an array or something like that. So just keep that in mind. There are some times where you just don't pass a value and you need default values. So here's an example where we are missing a default value and I want it. I really do want it in there. So what are we going to do? Well, React has this thing built in called default props, right? Problem solved, except for it's deprecated. What? Default props is deprecated? Are you kidding me? Who said this? When did this happen? Yeah, it's there. There's a big giant GitHub thread about it on the React, like official React GitHub page. I don't know what it's called. The repo on the official GitHub repo. There is a giant thread about removing default props. Now they haven't done it yet, but I know they definitely want to. And at the time I was against it because there is not a good alternative. I'll show you why. But this is gone. Like don't use this. ESLint, the ESLint rules don't require this anymore either. So this is what you would do in like, right? This is the first thing that came to my mind is, okay, I'll just use the equal sign. Obviously, I have a function component. I can just default the value myself, but it's not the same as default props. So React renders by calling the function every time a change occurs, meaning this anonymous function is going to get recreated every single time a change occurs. So that's absolutely not what you want to do. To fix that, you'll want to do something like this, where you have an initial onChange function that you've created out here, and then you pass it into your onChange down here. And you're probably thinking to yourself, wow, that's a lot of work. Yes, but it is the same as default props. Now, you can actually, now after I made this slide, I realized, well, I guess if you had default props already, all you got to do is down here, just do default props dot onChange. And then problem solved. Same exact behavior at that point. The important piece is to make your default props into a static variable outside of your component. And that way, when your component re-renders, meaning it calls the whole function again, you're not recreating all these variables on the fly. And if we look here, text input, if we look here, this is another way to memoize or create a default value that's safe for a function. But I've thought about this a lot. I don't think I recommend function prototype anymore, because if somebody modifies or mutates the onChange function in some way, they add props to it, that adds it to the prototype of function, which you really don't want. So I used to recommend this, and now I don't. But I do use function prototype where I'm doing some defaulting or storybook things or stuff like that, because it is a built-in memoized no-op function that it's really nice and handy. And I have a whole segment here about how benchmarks can be wrong, because there's a Stack Overflow that said function prototype is slow, and they ran 10 million iterations. And also, if you change the order in the benchmark, this person who did this benchmark and multiple people that did it, they ran the no-op function first and then the function prototype second. But then they never swapped the order, and they did it in the same process. V8, which is a JavaScript thing that it's an interpreter for JavaScript, it optimizes things, especially if you run them 10 million times. And it was optimizing based on the order of which one came first. It was optimizing. So when you ran function prototype after the no-op function, it looks slower. But it's weird, because function prototype is literally the prototype it's every function. Every function is function prototype. It's the weirdest thing. So I wrote a whole article about how the benchmarks are wrong and showed in my data that's not the case. And if you run it 1,000 times, which is still more than you probably ever have in your application, function prototype is faster in nanoseconds. Why does any of this matter? So just a thing to keep in mind: benchmarks can lie to you. Now let's talk about the Memoization Cascade. This is a really fun one for me, but probably not for anybody who's doing it wrong. So if you want, let's start. Put your eyes down here. Okay, we're looking at this use effect. We want to do something when the error messages change. So to do something when the error messages change, you would add error messages to the second arg. Done, right? But error messages is unmemoized. Okay, we got to find out where it's coming from. Oh, it's coming from up here. Okay, see, we're doing an equal sign. There's no use memo, whatever. And we're just doing a map on errors, and we're creating a new array. Map creates a new array. So therefore, we're creating a new array of errors. Okay, all we got to do is memoize error messages. Problem solved, right? Now our use effect is going to work correctly. Oh, wait, errors is also unmemoized. And we don't even control errors. It's coming from somewhere else. Where's it coming from? Oh, it's coming from props. Oh, man. Now we got to go look for which components are passing errors down to our component, and hoping those are memorized too. So we have to make sure to memoize all of them. We can't just memoize the error messages coming into our component, because it's being recreated every time. So now we have to memoize that, and then we have to memoize errors, and then we have to memoize whatever errors is depending on. Then we have to memoize something else. This is called the Memoization Cascade. And also, it could be a problem because errors might be coming from context. Oh no, errors is coming from context. Now I got to go look at this context provider, which who knows where that is. It could be multiple places, and I got to fix it in all those places too. Oh man. So Memoization Cascade, big deal. Big deal. This is why you memoize everything. It's because if you don't do this, you're going to run into problems that you can't fix. They're almost not fixable, because you have to fix them at the parent nodes and then in all of your leaf nodes eventually. You can't just fix them at the leaf nodes, because your code's just not going to work right. It's there's no even point in adding the second arg there at that point. So context memoization. Let's look at how you memoize with context. First, let's explain context. Here's how you create a context in React. You call this create context function. It gives you an object. It looks like a component. It's not a component. It has a capital letter because of how React renders, but it is a context, a React context. And then you can export it. Now, what's important here is I didn't pass any default values here, but I always do. I just didn't do it for the slide. I didn't have any room. But you will want to pass something into your create context so that it has a default value, because it allows you to render components in unit tests and other places without having to mock your context. Let's look at what form context has in it. It has a provider component. The provider component has one prop that it takes is value, and it passes that to consumer components. Now, consumer components are the old way we used to do context, where it would give you render props. And if you're using class components, typically this is the way you would want to go in the past. There's a better way to do it today. And the better way, I don't have a slide for it, but the better way would be to take form context and add it as the one context for your whole component. So it does suck. Like with function components, you can have multiple contexts. With class components, you can have multiple legacy contexts, but the new context API, you can only have one. Or you can do this .consumer thing. But because it uses render props, you're going to run into the same memoization problem. I absolutely don't recommend using this anymore. But in a pinch, I've had to use it for legacy projects. Use context is the way we do it with hooks. And we've discussed this already, but this is, you just pass the whole object here and it figures out how to listen to the React, whatever it's called, the like the internal context that it uses. And it's able to pick out the one that's for you. And anytime that context updates, then use context will force your component to re-render. So here's an example. I've underlined this. There's a problem here. There's a reason why I underlined this, and that's because this value is unmemoized. Context does not do anything special. It does not do any kind of props, like doesn't look at your props and check to see if any of them are different or anything like it. No, it looks at the value past it, like literally whatever value is. So in this case, it's an object that we're dynamically creating on the fly. You definitely want to make sure that is memoized, because if it's not, anytime this component re-renders, which could happen from props, state, context, or most likely the component, the parent component re-rendering, which includes any parent context providers. Any of those re-rendering would also cause this to potentially re-render, unless you memoize this component. That would also cause this to re-render, which means it will then force all of your consumers to re-render. Anything with a use context or form context.consumer, any of those will re-render anytime this parent re-renders, which can cause a chain of events to occur. I've seen it where you have your provider re-renders, and that re-renders like all the children, but then those children are also re-rendering because they have providers too, and then those are re-rendering the children again. So I've had like child components re-render 1,000 times in some applications that I got put on. And I was like, what is going on here? And I had to go in the profiler and find all it. Like, I have never used the profiler since I started doing hooks correctly. Since I started memoizing everything, I've not once touched that React profiler. Now, I've done it. Okay, so I'm lying because I do some intense stuff in React. And when you're rendering like 300 elements and they're all changing on the fly, you're going to look at the profiler. But when you're doing basic stuff, you never have to look at the profiler. But I used to have to do it because there's weird stuff like this happening where somebody didn't memoize a map state to props function or something else. And because it wasn't memoized, then you're going to wind up with these problems. And it's like, why when I like type one letter in the app, does the app re-render 1,000 times? You know, and then I'm looking at the profiler trying to figure out what caused it. And then you're like going through and you're finding out it's like 50 components are causing it. It's like, great, I can't fix this. So very important to memoize your context. And this is, we'll go over here, but any change to the provider value re-renders all context consumers. We talked about this. I'm just reiterating it. This is how you memoize the provider value, is with use memo. Now, it seems like this is obtuse. Why am I passing these values here in the second arg and then just assigning them to an object, right? But it memoizes it. That's why it's important. This memoizes your value. And then it's always the same object unless one of these have changed. Perfect. And now make sure also these values are memoized too, because if they're not, you're going to run into the memoization cascade. We're going to look at callback memoization again. This is going to come up multiple times. Here's an inline on-click function. So I've underlined it because it is an inline function, and that means it's unmemoized. We definitely want to memoize that. And the weird piece here is I'm not actually sure. I can't tell you if this forces the button with this key to re-render or all of the buttons to re-render. I'm not sure, but passing these inline functions like this is problematic. This is a use callback that we have created to fix the problem of that on-click being memoized or unmemoized. But, oh, we did it wrong. It's unmemoized. Why is this unmemoized? Keen eyes here. We forgot the second arg. Okay, so we're gonna add the second arg. Okay. Like, think of this like being a PR, you know? Right, somebody sends me code like this. Okay, we're gonna do this like a PR. Somebody sends me the code. I'm like, hey, it's an inline function. It's a memoized. Please memoize it. They write me this code. I'm said, no, this is still unmemoized. Please add the second arg. They add the second arg. I'm like, no, this is wrong. Okay, this is wrong. Notice that we have name here, and name is coming from props. Clearly, we need to add name to the second arg here. Why are you not like paying attention to ESLint? Okay, so it's not updating, right? Like our onClick never updates, but the name is changing. Okay, that's bad. So, okay, finally they added it, right? And then I have to go in the PR again and tell them, okay, now this only updates for name. You're still doing it wrong. You've got to now add the set active function here. Now it updates for all values. Why are we adding the set active function? You're probably wondering why I added this here. Because it's coming from context. You cannot guarantee that this is a state setter. You can't guarantee that this is never going to change. If you don't control this value, you add it down here. And ESLint will notify you about it too. The only time ESLint won't tell you to add something here is when you control it. So if it's a ref that you control, or if it's a state setter that you control, meaning it was created in your component, that is the only time you do not add it to the second arg. If it's not going to change, don't worry about adding it to the second arg. Like, add it here. It's not going to hurt you. It's never going to change, so don't worry about it. Just put it down here and make your code work. Because if somebody rewrites that code behind the scenes and this value does end up changing and you need to call the current set active function, well, it's not going to work right because you didn't do your code correctly. So it's very important to keep in mind that you always need to put all the stuff that you don't control down here in the second arg to make sure that everything works correctly. Eager side effect memoization. You're probably thinking to yourself, like, what the heck does that mean? I didn't know either. I had to think about it. So side effect memoization, we talked about that. That's got something to do with use effect, right? And eager. Eager means it's always going to do it. So let's see what happens here. What is going on? We are always going to do something. I've underlined the on change. What is going on here? Why did I do that? Okay, so we've got a use effect. Okay, so it's a slider. When an on change function comes in, we are going to call the use effect and give it the calculated value. That, to me, something seems wrong about that, right? It's like, definitely seems wrong, because when somebody passes me an on change, I don't think they want me to call it immediately. I think they only want me to call it when the calculated value changes. And this is actually an example of something I did wrong when I first started using hooks. I screwed this up on a slider component. That's why I named it that. This is legit. So I had this problem and I was like, oh gosh, how do I just, only when the calculated value changes, I want to call that the on change. Okay, so how do we do this? Because this is obviously wrong. This is going to call it, actually what ended up happening is it got into an infinite loop, because what happened is I called the on change, then slider created me a new on change, passed it in. I called the on change again, and then they created me a new one, and then I called it again, and it was just this weird loop. So you don't want that. And so what you're going to do is you're going to disable ESLint, because obviously it's wrong, right? There's no reason ESLint would tell me that I need an on change in there and auto fix it and whatever. It just disable it. No, don't do that. If you disable ESLint, when it's telling you something that is clearly wrong, you're going to run into other problems. Because what if somebody adds some other value here? Well, you're not going to remember to put it down here, and ESLint won't tell you either. Do not disable ESLint React hooks rules. There are other ways around it. To somebody looking at this, they're not even clear why the on change is missing. You might have added a second value and then just it's not working. They don't know if the second value needs to go here, if the on change needs to go here. They're not going to know. What they're going to do is they're going to delete this ESLint disable. It's going to auto fix itself if you have ESLint auto fixing. If you don't, you're going to have to do it manually. But then it's going to force you to add that on change here and whatever other values are in here. And then you're going to run into that bug again and you're not going to know what's wrong. So it's important to leave ESLint, the React hooks one, doing whatever it does. There is another way to solve this, where we only run it from when the calculated value changes using a ref. This is the example I was talking about earlier. We have a use ref, and we have this on change ref that we're creating. Then we're setting that value anytime the component sees a change. It's going to call the whole function. It's going to set this value and we've got on change, equals on change ref, whatever. We've got the set. And then whenever the changed value changes, we're going to call the latest version of that ref. And notice ref is not down here in the second args because it never changes. But if it came from somewhere else, yes, we would pass it down here. And that could be problematic depending on how your app's developed. I don't want to get into that right now. So this is an on-change ref. We don't have to pass it here. We control it. ESLint won't complain. And it tells somebody, hey, there's something weird going on here. We only want to call this when the calculated value changes, but I specifically made this a ref because I didn't want to pass this as a second arg. Like, that's what this is telling me if I saw this. If it's not telling you that, that's fine. I actually complained on Twitter about this problem. I had this problem. It was not this particular one. It was a different problem. And Dan Abramov told me the solution. So it wasn't like I just came up with this, out of nowhere. This is not my solution. This is something that he told me. And I believe him because this is the only way to solve this problem. I was very upset about it. When I went to ReactConf 2 years ago, I talked to him personally, and this is the first thing I complained about. And then I chose to be like, I was like, wow, he looks really tired. I'm not gonna bug him anymore. But I wanted to get this one off my chest. And he didn't create hooks. It wasn't like, he made this up and whatever, but it was really upsetting that this was the only solution that we had. But it does mean useref is very powerful. And again, it's very powerful. You have to be careful with it. Incorrectly mounting your component or incorrectly unmounting your component is another problem you can run into with hooks. Here is a set timeout function. It is a memory leak. Why is it a memory leak? Because if your component unmounts, this set timeout is still there. Now, technically, in this case, the set timeout kind of runs like immediately, so it doesn't really matter. But if you had a set timeout with some kind of timer, or you had more logic going on in here, or you had an event listener or something else, it would stay there forever. You can't just put it in your use effect. You have to stop the listener when your component unmounts. To do that, you're going to do something like this. And yes, I have seen this. I've seen people like not put the second function in there. So here's an example of how you can do it with set timeout. And I've seen tons of solutions of this. I had other slides that I added and I got rid of them because I was like, no one would ever do that. And then somebody did it at work like a week after I did this. And I was like, oh, okay, I guess it is something people do. I haven't re-added that slide, but I fixed it, right? In this example, I have a locals timeout ID in my use effect, and it gets scoped or closed over in this return function here, so that when a change is made down here, or that'll never happen in this example, or when the component unmounts, this clear timeout will get called with the correct timeout ID that we set when we first made our timeout. Now you're probably wondering what's going on here. Set timeout returns an ID, and then if you call clear timeout and pass that ID into it, it's going to clear that timeout, and that timeout, the function, the callback that you pass to set timeout, won't ever occur. This works with set interval as well. There's clear interval. And then with event listeners, it's a little bit different. Here's an example with event listeners where I created a variable in use effect. This callback is created in here. It's not created outside. I created it directly in my use effect. And yes, this is how I would recommend it, because remove event listener requires the exact same callback reference. It requires the exact same callback function that you pass to the add event listener. It has to be the same thing to remove the event listener. You pass this callback to both of them, and that's how you remove it. And if you're wondering why that is, there's like other specific reasons. Like you could use this callback multiple times. You might have it on different events. And so you have to specify the event and give it the exact callback that you want it to remove the event listener on. And I always define that callback in my use effect because I always have it a little bit more complicated. Sometimes I'm doing performance things and I have window.request animation frame. And I might have other listeners in there like mutation observer and resize observer and intersection observer. And there's a lot of stuff I do in a use effect where I'm listening to lots of events, and those callbacks always go in the use effect itself. It does not need to go outside. If you put it in a use callback, you can run into race conditions. It's best just to do it the way I have it here. Now, there are reasons you might not want to do it this way, and you can do it outside of here, but typically the callback itself, this function here is actually, I just typically make it in the use effect. Okay, there's something wrong here. You're probably wondering what it is, right? Like, what did I do wrong? Why did I underline this? It looks exactly the same as the previous example, but it's wrong because I'm not returning a function. Well, whoops. And guess what? TypeScript doesn't care either. Even if you're not using TypeScript, but if you are using TypeScript, it's not going to tell you this is wrong. Void is a valid return type for use effect. You can return void, no big deal. And so I'm returning void, which is undefined. I'm returning undefined here, and TypeScript's like, yeah, that's cool. It's not gonna tell me that you forgot to call a function. What are you doing here? This doesn't make any sense, But that's something to keep in mind, that if you do this wrong, it will cause weird problems. I've had it where I'm like, why isn't this event occurring? And I like go through all the code and like put logs in it. I'm like, it's not calling my log. What's going on, right? It's not calling it because I immediately cleared the timeout right after I created it. Yeah, you have to return a function. This has got me multiple times. I can think of like 4 times in the last year I've been hit by this. It's actually really annoying. There's another problem you can run into where you want to run a function only when your component unmounts. And I guarantee you, unless you know the ref trick, most people don't know how to solve this. So this is the thing that I ran into where I was talking to Dan Abramov, and I was like, okay, I complained on Twitter, and then he was like, here's your solution. I was like, this sucks. So there's a stop playing function, and the stop playing function depends on song ID. It also depends on audio players, but that's not changing. Song ID is the one that's changing. So what happens is this will stop the current playing song. That's what this function does. Okay, here's a use effect. I want to stop playing the song when the component unmounts, and only when it unmounts. At no other point do I want to call this stop playing function, because it will be called by itself when like if you click on a new song, it'll stop the song and then play the next one. You don't have to worry about it. And this is also a legacy project I had, but this is exact code that I was using. It's a little bit different actually, but it's very similar. So I'm returning from my use effect, I'm returning a function, right? Stop playing. Great. This looks like it will run when my component unmounts, and it does. It does run when my component unmounts, except for it's going to run the old stop playing function. It's going to return the stop playing function from when the component mounted, because this function has been closed over. It is wrong. You can't do that. So how do you fix it? Okay, you add it to the second arg, right? No, you can't do that. It's still wrong. You can't add it to the second arg because now it's going to stop playing it every time the stop playing function changes, meaning you click to play a song, stop playing updates, it's going to stop playing the song. Well, actually it's not, but it will play it. I don't actually know. Now I'm thinking about it. It's been a while since I wrote this slide. I don't know. This is still wrong. You don't want it down here. It's not going to do what you expect. It's going to try to stop playing the previous song when a new stop playing function occurs, but it might, whatever. For the purposes of the slide, I'm doing it this way because this is the way I ended up solving it. There was a reason why I didn't do that in my previous one. I just can't remember because I've slimmed it down for the slides. Here's stop playing. Okay, we created useRef. Oh my God, this again, right? useRef is so powerful. We have created the reference to the function so that when this gets called only on unmount, does it call the latest version of the stop playing function. This is something to keep in mind. You're probably seeing a pattern here with useRef. Yes, it is the most powerful hook. It is by far the most like ridiculously powerful hook because it can bypass everything. useRef is actually the same as doing this in your class component. So if you do this dot x equals something, that is the exact same as doing a ref. It does not force a component re-render, but you can store state that stays there forever in your component. This is extremely powerful. So this part, you're gonna hate me on this. It's not my fault. I didn't make this up. Yeah. So if you notice, remember that that ref assignment that we talked about before? Why is this wrapped in a use effect? Where's the second arg? What are we doing here? So if you don't do that ref assignment in a use effect, you're going to run into edge case bugs. I was told this by multiple people on Twitter when I was asking questions about it. The first person who told me this was Mark Erickson. He's the guy who made well, he didn't make Redux. I guess Dan Abramov made Redux, but Mark Erickson took over like a year after. So he's been doing it since 2016. So essentially, to me, he's like the Redux maintainer. So I was interviewing him and he told me about this and I was like, nah, like, what are you're crazy. And then I went and talked and asked people about it. And there were other people like, yep, because if like an error occurs or something happens, your component's processing, you can get the wrong value into the ref. And then I can't even explain all the problems with it because I don't want to think about this. I like, honestly, this sucks. I don't want to have to put a use effect around all these assignments. It just blows my mind. So, yes, you will have to do this. It's the right way to do it. No, I don't like doing it. It makes it even worse. If this wasn't already confusing, now you got to put the use effect around it. And you don't have to pass a second arg. Yes, you can. I can pass stop playing down here, but it really doesn't matter at that point. You're not gaining anything doing that. There are also async side effects. And you're probably thinking to yourself, oh no, what am I doing wrong? This looks perfectly normal, right? Oh no, I got you. So use callback. Why is this bad? It's a fetch call, no big deal. We're just getting some data. What's wrong here? Why is it so bad? It's because well, let me go back. It's bad because this fetch call can't be canceled. If this use callback gets called and the component unmounts, this fetch is still going on. It can perform side effects. It can perform memory leaks. It can do lots of things bad to your app. It could try to set state when there's no state to set. It could be doing lots of things, mutating refs. Like, who knows what this is doing? I have no clue. But what I can tell you is it's wrong. And that really sucks because I would like to use callback to do async, but you can't. You have to do the async in your use effects. That's for side effects. This is not for side effects. This is for callbacks. So in our callback, we'll set a state. And the state will force our component to re-render. And now it's a safe way of doing asynchronous stuff because our component will re-render. And if it doesn't re-render, no big deal. But if it does re-render, then we can capture that data down here. We can listen to when data updates, and we can have our use effect execute the fetch when data updates. This is a very reactive way of coding this. Look here, we have a abort controller. What the heck is this? What is all this code? The fetch was so simple before. So what's different here is that you can't cancel promises. It's not an observable, and that sucks. But you can cancel fetch calls. You can cancel fetch calls with a signal. Now you can also cancel XML, HTTP requests, stuff like that. But here, this is how you do it with fetch calls. This is more recent. But you use abort controller, however funny that name is, and you give the fetch a signal of the abort controller, and then you call the abort function, and then when the fetch notices that the data has come back, it will check the signal to see if anything has changed, or it'll check the signal to see if it's been aborted or not. And if it's been aborted, it then won't call your .then or .catch or whatever. It won't do anything because you've already canceled it. It's a little bit different than XML HTTP requests, because on that one, you can actually cancel it. Like, you literally just cancel it. And if you look at your network tab, it'll say the call was canceled, and the browser doesn't even care at that point. But in this case, as far as I know, the browser is still getting the response back. Maybe I'm wrong. It might not even be getting. I don't even know. It's been. I'm not sure. But this is how you write the abort controller. Using use layout effect. Okay, so use layout effect. You've probably heard of it. You probably don't want me to say anything about it. It's synchronous, and it's like use effect but synchronous, except for it does not work server side. Keep that in mind. Use layout effect is for immediate DOM manipulation, or where you need something immediately, like the like measurements of some box or something like that. Now, I have never ever found a use case for use layout effect, but after I did this presentation the first time, people told me like, oh, the use layout effect, like there a couple times I've done it for measuring something. I was like, okay, I've still never gone into that. I even wrote my own image cropper at work recently, and I still haven't used use layout effect. I've even tried, like, I put use layout effect there, and then I switch it with use effect, and it worked the exact same. I can understand why you need it. Like, I get it, because it can prevent an extra re-render where you don't want it, but I've never had a use case for it. So just something to keep in mind, though, is it does not work server side. And if you have it in a server side component, React will definitely make it clear you're not supposed to do that. Why is this here? It's a hooks gotcha. You cannot use the use layout effect server side. If you want to do that, you need like a use memo or something else. Don't use this hook for that. If you're going to put a use memo in there or use effect in there, just know that it's not going to run server side. There are other ways to run things server side. Use layout effect is not the way to do it. So what's a hook loop? Uh-oh. Okay, so far we've talked about components that have a single hook, or like they have multiple hooks, but they're like, what about this? What if you got a loop? What are you going to do with a loop? So get some button data. We're going to render a button. Uh-oh, we did this inline. Okay, but I added the second arg, right? It should be okay. Yeah, it does. It is okay, as long as you don't change the number of items in button data. If the number of items in button data changes, this is totally going to break. Or if the position of the items in button data changes, this will break too, in ways that you're not expecting. Do not put your hooks in your DOM, please. It is wrong. So the way to solve it, you're going to do this, right? This is somebody's going to send me an UPR, and they're going to be like, okay, I fixed it. See, I created button callbacks, and I mapped this, and I put a bunch of use callbacks in a loop. No, stop. Don't put your callbacks in a loop, or your hooks. I mean, hooks don't go in loops. The indexing is like super important. You don't do that. Any change to the number of hooks breaks React. You do not change the number of hooks. You don't change the order of hooks. You don't touch hooks. They are rendered sequentially. So how do you solve the problem of, hey, I need to loop something, but I also need use callback? By not using use callback. You use memo. Do your loop, add the callback as a property in a use memo. So now you created a new array that includes this on-click data. And then you can render your buttons. Now that this is memoized, now you can render your modified button data that includes the on-click, and that on-click is now memoized because it was memoized with all of the modified button data. Now, that does kind of suck, because like, what if you want to, like, how do you dynamically create this if you need to, or if you want to kind of memoize it differently? There are ways to do that. This is the interesting thing, is that this is like a totally different way of developing components. Not this. This is how you're probably doing it potentially. But there's a thing I came up with to allow you to do compound components where you don't have to pass this on click directly, and you can memoize this value just like this. But it, like, you don't have to memoize it in a use memo. It memoize it in a use callback, but you're rendering with children, and I don't want to go too deep into it, but it uses context. My form library, OneForm, was built that way, and it allows you to get around this problem of, okay, I'm looping, I'm passing on click. Well, how do I fix it? It's a little bit more intense than people are probably used to in terms of how to do the code, because it is a fundamentally different way of thinking about building components and composing them together. But it does get around this problem, and it's not a workaround. I actually feel like it's a superior way of working around this problem. Okay, so what do I even mean not using React components in this slide? So I'm saying not using React components. What does that mean? If you're not using a React component, okay, how does that relate to hooks? Well, we'll get to how it relates to hooks. But first things first, what are we doing here? So we're calling children as a function, and we're passing it child props. No big deal, right? Yeah. So you want to use the Createelement function that React does internally, that Babel will use. You want to use this Createelement function and pass it children, and then pass it child props as two different arguments. You do not call children directly. Absolutely never call children directly. That calls it as a function. You want to make it a React component. This creates a React component out of your children. And Createelement allows you to render components, however weird that is. Let's this is like a basic example. Okay, so this is correct, right? This is correct. We have my component. I see it right here. There's my component. And then we're rendering another component and potentially passing it props. And another component shows up, and it's got some H1 and H2 in it. Great. If we do it wrong, so we're going to call another component as a function and pass it props. Yeah, I can just call it as a function. It's just a function component. Oh, wait. Where'd it go? Where it goes, not here. Wait, my component has H1 and H2. No. There's no H1 and H2 in my component. And when you get hooks errors, guess where the hooks errors are going to be? They're going to be in my component. They're not going to be in another component, because you've essentially assembled the hooks from here and put them into this one. It's really bad for debugging. So when you call components as functions, the hooks display errors from the wrong component. And also, your dev tools don't work. Like, the more you call a component as a function, your dev tools just simply won't work for you. And that's really awful. Like, to do that to another developer who has to then use your components and try to figure out what's wrong, they're not going to see that component in the dev tools. They're just not even going to know it's there. And it's going to be like showing errors in some other component. They're going to be looking there, everything looks fine, but the error is coming from an inner component, a child component, but that child component is not returning the error because it doesn't exist. You never rendered it as a React component. You just called it as a function and then returned some value out of it. Another issue people get into with hooks are when they're untestable. So hooks are not class methods. We talked about this. This slide's kind of weird now. So you can't test hooks in a component. That's what's different, right? So with class components, you could test the methods. You can just straight up, like enzyme and stuff like that, you just test the methods, but you can't test hooks that way. But you can test custom hooks. And custom hooks are a collection of hooks. So what does a custom hook look like? Here's a custom hook. Use song player. It gets something out of context. Okay, so this is a collection of hooks. So we're adding a use context, we're adding a use callback, and then we're returning some values. And this returns a start playing and stop playing function. Pretty easy. Now, if I want this to do a side effect, meaning if I'm not going to return anything from my custom hook, ideally you would put the word effect up here in the title. So use song player effect. That way you can make it clear to somebody using that hook that is a side effect hook, and it does not return any values. It makes it really clear, and it uses the same nomenclature as React does. But this is a really easy way to create a custom hook, and they're very simple to make. I highly recommend using custom hooks all over the place. How do I test hooks? You're probably still wondering that, right? Like, that's the whole reason we're here, is like, how do you test the hooks? Okay, testing library, right? Everybody hears about this. You use it for React components, right? So you can just test your hooks that way, right? Although testing library is actually a set of testing conventions, and they're for the UI. They are actually not for logic. So you can't use testing library. But you can use React hooks testing library. And you're probably thinking, that's the same thing. No, it's not. React hooks testing library is a separate library for testing individual hooks. And it is not the same API as testing library. So testing library has the exact same API, whether you're in Cypress, Jest, Jasmine, any other platform. Testing library has the exact same UI code and methods and whatever. But React hooks testing library is not the same. It is different. And honestly, it's weird that it's called testing library, but I mean, it's a nice testing library for React hooks. I do use this myself in my OneForm library. I use it all over the place. So I do recommend using React Hooks testing library and creating custom hooks. That way you can test your logic and you don't have to test the component rendering. You can test your component library rendering in Cypress and not have to do it in Jest, where you don't have a DOM, or you have a fake DOM that doesn't have everything. Okay, so conclusion, we're done, right? No, we're not, actually. I want to avoid computer science. I really don't like it, but memoization is all about complexity, and it's about big O. And it looks like this. And you're probably going, what? So the point of big O here is that reducing re-renders reduces subsequent re-renders. Then you can reduce subsequent re-renders and reducing subsequent re-renders and whatever, and so on. And that gives you a big performance impact. I have seen the performance impact of not memoizing and then memoizing as clutchy as I could on top of that. Like I fixed an app which did not have memoization. I did my best to memoize where I could, and there was a significant performance improvement. It was so bad that you're like typing in the keyboard and you can literally see the letters coming in one by one. And I'm like, this is so slow and laggy. What the heck is going on here? And the solution was to memoize in places where I couldn't do it everywhere, but I could do it most places. And then it was like, wow, this feels great. Oh my gosh, it's so good to use. I'm typing and it's typing and it's showing up and I can see, live updating of the site over here and I didn't have to worry about it. Conclusion. Yeah, this is for real. Memoize all the things. And I have 2 YouTube channels. This one, I interview a bunch of JavaScript developers and of libraries, and I put my talks in here too. So like, here's my OneForm library talk, and then this one is just me coding. And if you want to watch me code or code the OneForm library from scratch, you can watch why I made certain decisions. But also you can see me do funny stuff like FizzBuzz and like, okay, how's this work? And I'll just do it functional. Or like this LeetCode RxJS question. LeetCode does not support RxJS concurrency. It doesn't support any JavaScript for concurrency. And I was like, nah, I could do it. So I did it with RxJS. I even have another video where I did it in C++ style with classes in JavaScript. So these are channels I have where I put my stuff. And then also I have this OneForm library. It's really, really cool. I highly recommend it. We use it at Minted today. It was actually built off of technology that we originally had at Minted. So we had form library technology. Then we built something called Minted Forms. Then I built OneForm. So I got permission. I was like, hey, I want to make this and I want to open source it. And it was like, well, we can't open source it. It doesn't have unit tests. It's all like one big component. We can't do that. I was like, okay, fine. I'll rebuild it from scratch. So I got permission. I rebuilt it from scratch. This is mine now. So I made this library and it's so good. We're using it at Minted today. And we just used it on a recent project, just got it done. It was so good. It helped us accomplish that project in a way where we did not tightly couple our forms. And we had all these different settings. They could all depend on whatever they needed to, but they were also rendering in their own components. And they can initialize their initial values, whatever, from data in their component. But the form itself didn't care about any of that. It didn't have to know about anything. All it had to know about, did you submit it? That's it. It was so nice. All right, so now we'll get to the final questions. This is the end of the presentation. There were a bunch of them. I saw them come up, but I haven't read them yet. Does somebody want to pop on and tell me any questions that I maybe missed?
Yes. Let me go ahead and see if there's any questions real quick that may have been overlooked. Let's see. I think most of them are kind of statements and questions besides that. We got some praise in the chat though. That you're doing such a great job.
Yeah, Kevin, one question I think I don't believe it was answered from Into the Nature. If we memoize everything, will this affect performance? Do we need to know what to memoize?
Yeah, so I don't think it's easy to know what to memoize and what not to memoize. Like I've heard there could, like, I think it was Kenzie Dodd said something like there's a performance impact from memoization. Yeah, but it's a positive performance impact. Like, from my opinion, in all the apps I've worked on, I've not seen memoization cause any degradation. In fact, it's only solved problems I've come up against. And the main reason is it prevents DOM re-renders. And you can loop in nanoseconds, like, nanoseconds. I don't even know what you would call it. Micron seconds. Like, the loops happen so fast in JavaScript to do these comparisons. And they're just equivalency comparisons. So they're not doing deeply nesting or anything like that. There's no n squared. And now technically it's n squared if you think about how many loops could happen for memoization. But the JavaScript execution time is so much faster than the DOM execution time. You definitely want to avoid those DOM re-renders. And that's why yes, there's a performance cost to this memoization, but no, it's like negligible in comparison to DOM re-rendering. And that's why I always memoize all the things. And I've been doing this at work for 2 years now, I think. So I've forced everybody to memoize all the stuff for 2 years. We have not noticed any performance problems at all, and at least not with the stuff that I've been reviewing in PRs. Like if it's something I didn't review, like who knows what it could be, or like existing legacy applications. There are things that I didn't control when they were built, and so that never happened. But this is something I've been doing, and I've been forcing it because I realized you're talking about the performance impacts of it. We had that memoization before. Apps had like Redux, and they had the connect function, and we had class components, and we were doing all of this memoization in the past. And then all of a sudden we get to function components, and then that goes out of the window, and people don't realize that there's actually an impact to what you're doing. And then we move to render, what do you call them? Render props. And that was even worse. Now we're like creating new props all over the place and passing them directly. Like when you do a render prop, that creates a new function that creates a new children. That means your children are no longer memorized. So I was like trying to find ways to memorize children and render props. And then I saw this announcement about hooks, and I was like, oh my God, this solves all the problems. As long as you use hooks. If you're not doing it, you're going to cause problems. So here's the thing is, yeah, like there could be a performance impact. I know, like, it makes sense that you're just, there's extra loops, but you're also preventing ridiculous amounts of virtual DOM diffs and DOM renders. So in the grand scheme of things, you're preventing more than you're creating problems, and also it prevents the memoization cascade. The main important piece about memoization with hooks is if you don't memoize everything, you're going to run in the memoization cascade, and your hooks are useless at that point.
Yeah, like so Kevin, it's Fabian. I agree that so memoization is your friend on in all this, but it's also really developers as a team. They also need to make the call, or like how, I guess I don't say how expensive, but like I guess the cost benefit of this re-render operation of this small component. Now this is like, so for example, let's say we're talking about the component let's say the component in discussion here is the page itself, right? Like let's say the Facebook profile page. Yeah, best believe everything at that level and everything above it should be memoized. But like, let's say it's like the profile, the name, the name on my profile page, right? It's like, well, if we were to, I guess, like going into into the nature is question, would there? I do remember seeing that there's I guess like a cost to memoization, and if you were to memoize everything, like and I'm not saying that you have to give an answer here, but I think it's kind of like one of the things that you need to you got to weigh out the cost benefit of it all. Like how is it going to affect performance? But I don't know. Is it in your eyes, like if it's a label, right, or like I don't even want to say a button, because a button can trigger a re-render, a huge re-render. But I don't know. Yeah, like with that statement, is that something that you kind of see, you would agree with, or still in your eyes everything must be memoized no matter what?
Yeah, I think the thing that you want to think about when you're saying, oh, well, maybe you don't have to memorize everything. The first thing you got to worry about is memoization cascade. But the next thing you got to worry about is how can you tell developers when to and when not to memoize? How can you tell them when it's safe to do it? And what happens if you end up like taking those hooks or that bit of code and copying it to a custom hook and then using it somewhere else where it's actually more impactful than it was before? And so the problem is really realizing when it's important. I can't tell you. I've done React enough to not know when it's safe. I've tried in the past. I've tried to remove memoization, whatever. But I feel like, and so here's the thing that I talked to one of the guys in Kansas City, who's another presenter. I talked to him, and the main thing was, he was saying you don't need to use it everywhere. And he gave some good examples. Like at your provider components at the top level, you don't necessarily need to do it. But then I realized if you re-render one of those providers, if some, state changes or something, that actually causes all the children re-render, including all your other provider components, which causes their children to re-render. So, I mean, you can definitely get into lots of problems. The main thing is, I've run into tons of performance problems with React, tons and tons of performance problems because the DOM re-renders like are super slow. And maybe it's just because I'm more sensitive to it, but like I'm looking at the frame rate and I'm looking at like my slider and I'm saying, wow, the mouse and the slider aren't lined up anymore. What is going on here? And then I memoized everything. And as I added memoization, it was speeding up. And I was like, oh my gosh, now the mouse and the cursor are 101 and it's perfect. And I recently wrote an image cropper, and it had to do some weird things, or it had negative width and height because it had to, I don't know how to explain it with transforms, what I was doing, but you would drag around the crop box and you could see the image in the crop box not being aligned with the image outside of the crop box. And I had memoization in there, but it wasn't like done good enough. There were ways to improve it. And when I improved it and improved the calculations and the code I had there, then when you drag the box around, it's perfect. You can't see any difference between the crop box and the outside image that's being like overlaid. So I've run into lots of situations. Like I was saying before, I was, I render like 300 items and they all have to be changing and things like that because it's some stadium view. And you have to, this is like for a side project, but it's like a stadium and you got to see all these different things changing. And that was another situation where I was like, wow, not only do I need to memoize, but I need to put like extra, I need to use ref in ways that I didn't even expect because I needed that extra performance that React doesn't have when you don't memoize things. And also, I should say, at work, I've ran into multiple projects where the performance was horrible because the memoization wasn't there. And I was watching in the profiler like thousands of updates occurring. And that was a pretty hefty app that also rendered like it was a website renderer or website editor, I guess, at that point. So it was a little bit more hefty than most apps. But I've consistently run up against problems where React performance is an issue, and memoizing tends to solve that for me.
All right. Any other questions? No? All right. Kevin, are you still with us?
Yeah.
Okay. Well, if we are done on all questions, thank you so much for your time tonight. It was amazing. This was an awesome presentation. I'm sure everybody is going to walk away from this more educated on React hooks than they would have imagined. I definitely feel that way. I felt like I understood React hooks until this, and now I realize there's so much more to it. So really appreciate your time. Nick, I don't know if you are on here, but I know that we were going to share your YouTube channel in the chat to make sure everybody had that. And then also to remind everybody that this recording will be available on our YouTube channel as well for those that want to watch this another time or, revisit some of these concepts that he shared with us. And thank you again. Appreciate it. And maybe, in the future, we'll have you present again with us.
Thank you very much.
All right.
Thanks so much, Kevin. This is awesome.
Yeah.
Yes. Do what, Kevin?
Oh, I said, thanks everyone for coming too. I appreciate you coming to my talk. Like it's nice to have feedback and get stuff in the chat. And even if people, don't agree, it's nice to get that feedback regardless, because there's always things I'm thinking about and I can always change my mind if I don't agree with something. I've changed my mind plenty of times, like function prototype. I've changed my mind on that recently.
Yeah, absolutely. Agree with you. It's good to get everybody's feedback. Anything else, Fabian, Nick?
No, that is all. Thank you so much, Kevin. That was a great presentation. So thank you again for stopping by and giving this, some of your knowledge.
Yeah, thank you.
Yeah, right. I guess the only note that I have is next month we're going to actually I don't even want to say next month. I'm saying in a couple of weeks we're going to be having Eve Porcello give a talk over Defer and Stream. So if you can make it, please do. We're very excited and fortunate to have Eve give another presentation given her busy schedule. So I just want to do a quick shout out on that.
Cool. Okay. Thank you, everyone. Thank you again, Kevin, for your time. We do appreciate it. And we will see everybody in the next run.